All right, so I see people joining in. Hi, everybody. For those that already hear me, we're gonna give it a minute or two for everybody to join in. I already see around 30 people in the call. So for your information, everybody's muted by default, so we will not be able to hear you. If there is a question or you don't see something or hear, just shoot us a small message in the chat. So like I said, we're gonna wait a minute or two for everybody to join in. I have around 40 people already in the call, so let's give it a minute or two for people to join. I hope everybody can see already the PowerPoint presentation and with the title. If by any chance you don't see it and you don't see my face, feel free to send a question in the chat. All right, thanks for giving us a word, Danny. So we'll give it a minute or 30 seconds more because I still see people are joining in. It's more than 50 people in the call now. Give it another 30 seconds and then I'll slowly start, okay? All right, it's 12:03. Let's give it a go. I hope you see Peter and I. So we're going to be your hosts, and I'm coming to the introduction slide. But before I present Peter and myself, I'll just advance to the next slide. So why are we here? Why are we doing this this small workshop, let's say, or webcast? Well, we would like to talk about the evolution of data management over time and to what it evolved today. Okay, I think that's quite important. I think there's a lot of movement there. There's a lot of technologies, a lot of concepts in the market. So let's give it a view, and I'll try to give my view on the subject and what I see from my customers and our customers. And we obviously have Snowflake in the house helping us out and giving their side of the story. So it's about the summer that's coming, okay? And we're going to talk a bit about DataLake, so that's convenient. But at the same time, we're going to talk about snowflakes, so that's a bit strange. But since we're all in home, it doesn't really make a difference. It's about hunting for the missing piece in the new age of the analytics as well. So what's the missing piece, and let's try to demystify that a bit today. And what is driving that? So a lot of companies are talking about data-driven strategies, and well, their strategies to become data-driven. So what does that really mean, and how does like data architecture and modern data architecture, how do they address that? And what are the roles that drive it? We see in the past it was mostly IT that drove the data-driven concept, and whereas today it's more business and CXOs. And also, what about the changing needs in the market of the people that we need to serve with data? So the data experts, who do we need to address more, and how do their needs change? We can think about that, like the new age managers that come on seats today. These guys are going to be writing Python and Go, so they might be less interested in some other old school technology. So, but let's give it a view. And the question, there's a question that I had recently is like, as we go along in time and as these needs are changing, are we actually moving away from enterprise data warehouses to look at new data warehouses again? So this is actually the crust of this whole session. So my name is Luca Rister. I could be called a data innovation professional. I'm trying to find innovative solutions in the data domain, and I work for Business&Decision, which is a consultancy company, as a part of the Orange Business Services, or the Orange Group. I'm joined today with Peter Janssens from Snowflake. So, Peter, can you present yourself quickly, please?
I will do. Thank you very much, Luca. So my name is Peter. I'm working for the company Snowflake, the supplier of the cloud data platform. Been with Snowflake for 2.5 years now. I'm the gray-haired guy in the room, so to say. So I've seen business intelligence, information management happening in the in what today is being referred to as the legacy systems, and over time grow into data warehousing. Big data has been a term for a while, and this has grown into the data lakes and the data platform that we see today, and the implementation of cloud products. So my job today is to give you a feel on how Snowflake works in that constellation.
Great, and thanks for doing this with us, Peter, today. So on the agenda today, we have we'll go through a short introduction again, and then we'll look a bit on the comparison between these evolving data platforms and let's say architectural topologies. So looking at legacy BI, and then what it was and what it is, and then big data, how did it came to the picture, and then what's the next generation data platform looking like. We'll talk a bit about success stories. We'll somewhere along the way we'll go a bit deeper into Snowflake, not really deep technical dive, but a bit of an overview that Peter is going to give us. We'll look at success stories as well, and then we can go ahead to a poll, simple poll, and a Q&A. If you have a question along the way, feel free to put it in the chat, and we'll try to answer it at the end. So yeah, I hope you can you all hear me well, and we can continue. So in terms of introduction, I think Peter said it. I mean, I started like more than 12 years ago as a BI developer. So I was in that orange part. So on-premises data warehouses, was implementing ETLs, and you can kind of I think we all know what the downsides of those systems were. They were usually not adapted to accommodate all types of data back then, but maybe back then even, or 15 or 20 years ago, it was not necessary. So we talk about aggregated data mostly, and it's usually was not for all the users. It was more for management reporting, and yeah, a bunch of reporting, let's say. It did provide fast answers, and it was based on relational DB type of technology. Okay. Then as we moved along, we kind of moved those data warehouses to the cloud. So we had more cloud capabilities, but the principles stay the same. So either infrastructure as a service, or even some services that were software as a service that were used, but basically to bring us the same type of features with maybe more scalability and more elasticity. Okay. And then at some point we had the introduction of big data. I would say 15 years ago, something like this already, but it really commoditized like 10 years ago, or even 7 or 8 years ago. We saw a big peak of Hadoop and kind of data lake type of topologies. Basically, the goal was to enrich our existing analytics platforms with more storage and a different kind of storage, mostly immutable storage for file ingestion. So we can get those streams of data in. We can get semi-structured data in, like files, images, video, whatever. Okay, so, and a lot of people, I think, thought that this would kind of be the magic wand to solve all problems, but actually for us technical people and architects, it actually brought a lot of complexities, which I'll show in one of the following slides. And then today we can talk about cloud data platforms, or next generation data platforms that bring a lot of those features from the initial generations, from previous generations, that they brought them now into the picture, into one single platform. So let's see how that evolution actually went. So if you look at typical legacy BI platforms, I think most of the people around the table will notice. So we are taking some data sources, mostly OLTP operational data sources or enterprise applications. We're bringing this data together through an ETL where we crunch the data in a batch, typical batch fashion, and we bring that to the enterprise data warehouse, a big centralized storage, which allows us to do analytics on top of that. How do we do analytics and reporting? But we usually create data marts. Okay, most of the time. So if you look at methodologies and frameworks like Kimball and Inmon, or even Data Vault, yeah, we will talk about data marts on top of the enterprise data warehouse. We rarely go directly to the data warehouse to facilitate that speed in compute and to have a central kind of view of the data. Okay, it's designed for massive batch processing, like I said, and mostly structured data. I've been on projects where we needed to integrate files, but it's a lot of structured information, and it's really optimal for analytic reporting and dashboarding. So what are the limitations of those platforms? So in terms of technical limitations, it's very limited to integrate less structured data. Here we can talk about like machine information coming in messages or XML files, and then also like images or video. It's definitely not fit to accommodate that need. And also in terms of volumes, legacy BI systems really had restrained volume, so we needed to take care of every megabyte of data that we stored in operational databases. Oh, sorry, these relational databases, and also pay very strong attention to indexing and partitioning, etc. Schema and write rules the game in this world, obviously. So we take the schema as it is and we use it the way our business stakeholders asked us to do it. So we kind of conform the whole model to the needs of the business, which makes it a bit rigid and it takes time for us to make changes. And also we lose. So we have limited and costly scalability. Yeah? So back in the day, I think it was quite difficult to add nodes, etc. So add more compute. That was you needed to buy servers and racks, etc. And also, lastly but not least, we lose a lot of fine-grained information. So, like I said, it's mostly about aggregated information. In terms of functional limitations, well, we have important design complexity that needs to answer a lot of different needs from a lot of different departments. There's this always famous struggle between the financial and sales information. How we do this? Do we have separate data marts or single data mart? And then what about the rules of those of the loading that we needed to do? What about those, and how do we construct them? We have data availability constraints that are usually solved by replication in data marts. We have some maintenance costs, maintenance constraints and costs, obviously. And we are talking about fixed data structures, so we are slow to change those. And it's difficult to access new data sources, so we need to go through the same procedure actually to be able to access all the data. So we can conclude that it's not really addressed to the full extent to address. It's not capable to address to the full extent the today's needs in terms of data. And when companies say data driven, they have much more in their heads than just BI. So if you go back to that picture and we see the evolution. Next up is we are bringing in the elephant in the room. So what we've done and what most of the companies, a lot of companies have done is they brought the data lakes in the picture. Okay, so the elephant came in. We have that massive storage. We are able to now start loading web and log data, less structured data, Twitter data, whatever social media data. We're also able to offload the OLTP databases fully to data lake, so we don't need to aggregate or anything. We just fully dump the data into the data lake in a batch or even streaming type of mechanism. So that's quite handy. We have all the data necessary. Our data scientists is super happy if they can have access to the data lake, which is also kind of oftentimes really difficult to give because of the governance, etc. But we kind of fit more and more needs of our customers. Okay, but that doesn't remove the legacy BI stuff, right? So the enterprise data warehouse is there. It still needs to be there. There's this row. There's this arrow between the data lake and the enterprise data warehouse, because we still need to aggregate some reports. We still need to service our business users with data marts and reports. That still stays the same. But we can say that it's the data lake itself is a low-cost storage capability that we add to the, let's say, the modern data landscape. Okay, and we are able to manage in it all types of data. It's really designed for scalability and high processing capability. So it also allows us to kind of decouple the compute and storage, which is, I think, a big revolution during that time. So we could have really separated compute and storage, which was quite handy, whereas in the traditional relational databases, it was not the case. And it was great for storing. It's still great for storing all data and performing data science on top of this. So data scientists became very happy when they started having access to the fine-grained data. Okay. So what are the pain points? If we look at some of the technical pain points, but it's constantly evolving technologies, and they are oftentimes not always mature. So when we talk about Hadoop, okay, obviously it's an open source technology, and then the Hadoop ecosystem with all types of different types of frameworks inside and engines. Just to give a small example, we talked about MapReduce before Spark came to the picture, right? So I met clients that invested a lot of time in coding MapReduce type of ETL jobs, only then to realize that Spark is much more performant. They need to shift. So these things are moving quite often and quite fast. The data pipelines are complex, meaning that they're also costly, right? So we need to maintain those. And in terms of tools for the ETL jobs, well, most of the time we need to rely on coding. So that's one of the let's say pain point. It depends on who you speak to, obviously. We have different tools and approach for batch and streaming, so we can choose from multitudes of different frameworks for streaming. For example, we have Kafka, we have Flume, we have Flink, we have Samza, we have Akka. So a lot of different types of frameworks and technologies that are around there. And also, if you look at data lake specifically, AC transactions are not supported. So meaning, well, they are now with some new frameworks, but most of the time when you talked about data lake and the storage capacity, okay, you were not able to do upserts, for example. So if you needed to update something, you were not able to do that. So you needed to kind of replicate your data sets, which kind of led us to a lot of problems in terms of organization and governance in terms of files. When we look at functional and organizational pain points, well, it does not always fit well with typical BI use cases. So data lakes are there more on the technical side and more on the storage side. So that's one thing. Basic data exploration is difficult to perform. Let me explain that. So if we look at really raw files, we still need to confirm that this information and make it into something that becomes really plausible information, or rather than just pure data. So we kind of remove that layer of let's say making the data pretty for the end users. Data is, like I said, data is duplicated many times potentially, and it gives us a lot of efforts to keep the data management under control. So this data swamp syndrome comes in place. So to recap, data warehouse is definitely not decommissioned. We can save a lot of costs, but in terms of maybe storage and what data we bring into the picture, but maybe less in terms of management and maintainability. So we look again at the same picture, and we see the next evolution coming up. So when we talk about next gen data lake or next gen, let's say, data platform, we would like to see something like this. Okay, so I'll just go quickly back. If you look at the number of arrows here, and this is not exhaustive, obviously, we have what I call now is like integration mesh. So not mess, but mesh. So where we have really like different arrows going in really a lot of ways from various different technologies. And it'd be ideal if we could have everything in one place, right? Data lake and data warehouse in one place. So this is actually what the next generation data platform should look like, where we have one single place of truth and data, which is easily accessible by everybody, data scientists and business alike. And this is actually the vision and the evolution that we see today in the market. And that was the missing link between when we were actually in this mode, where we needed to think constantly like, okay, we have all this data in the data lake, we perform ETLs now in the data lake as well, but we still need to output this result somewhere. So we cannot really keep it in the data lake. So that was the complexity. So a lot of, and then we need different tools to manage that. So quite a big change if we move to something like this. So it is actually, to make it short, we would like to take the best of both worlds, both BI and data lakes, to answer a large spectrum of use cases. So, and what we can observe, to recap that, in the market today, and what our customers are usually looking for, is this end-to-end data vision. Okay, so really one place and end-to-end data vision. Less work with files and more SQL. So we see that very prevalent. So a lot of times clients, customers are like, we have data lake now, but okay, I need to work in files. So give me SQL back, you know. So that's also another interesting thing. We need to have highly secure environment. We need to have great performance and scalability and elasticity. We want to have minimal maintenance and optimization work. We need to be able to choose our cloud vendor and applications. We need to mature and involve. We need to have a strong community around that. That's quite important. And did I forget something? There's probably plenty of things that we can think about. So if you have something in your head, type it in as a question and we'll address it later. Okay, so there's a lot of desired features, which brings us to the fact that, first of all, we need a Swiss Army knife to answer all those needs. And it brings us to the Snowflake. Okay, so I'll invite Peter to take over here and give us a bit of a view on what Snowflake has to offer there.
Yeah,
Peter?
thank you very much. Thank you very much, Luca. So the cloud data platform, we at Snowflake are trying to implement exactly that Swiss Army knife that Luca is describing. Hopefully the slide will move forward. Here we go. This is very similar to the slide Luca was showing. It's a mesh, but not a mess. I love that term. I'll use it very often, probably in the near future. Where you see
I expect some royalties then.
There you go. That's a promise. The key thing I would say there is really that this type of implementations allows the user to execute on business intelligence dashboards against a data warehouse. It allows the user to do data science on their data lake and try to figure out what the data is telling us. It does allow companies to take the results of those analytics and combine them with the data in or the results in the dashboards. But like I said, it allows you as a user to do all those jobs. And basically, if you're in insurance company, then your job is really insurance. If you're a bank, your job is really finance, and so on. Your job is not managing files, like Luca was saying, more SQL, less files. It's not managing the files. It's not managing the results of the analysis that need to be combined with dashboards and so on and so forth. For me, I always like the analogy of cars. So when I want to drive from Amsterdam to Brussels, I just want to get in my car, start it, and start driving. I do not want to start building a car, basically. And that's really what Snowflake is all about. And like I said, I'll probably be using that Swiss Army knife analogy as well. So if you look where Snowflake lives, again, waiting for the slides to forward. So let's go ahead and not too happy with the response speed on this one. Oh, here we go. So the data lives in the cloud, basically. Why do we put data in the cloud? Because that makes it physically easily accessible. You just connect to your favorite cloud provider, either AWS, Microsoft Azure, Google Cloud Storage. because that's where your data is going to be. So it doesn't really matter if you're in Amsterdam, if you're in Tokyo, if you're in Sydney, or if you're in New York. You just connect to the data as it lives in the cloud. Because that data lives in the cloud, we can use relatively cheap cloud storage. Typically, cloud provider asks something like $20 or $30 for a terabyte of storage. And the whole concept of database becomes a logical concept. So I can have a database, I can have multiple databases, I can have data lakes available to me in the cloud, and they are all there from a logical perspective. Like Luca was saying, more SQL, less files. I don't care about how those files are physically stored in the cloud. I just want to be able to access that system as if it were a database, using a database language which for decades now has been the structured query language, is SQL. So to be able to access that data, I don't actually want to physically worry myself about files, but I want to use what we call a virtual warehouse, a compute resource. Like Luca was saying, the separation of the physical storage and the way we use that data, the compute resources, is paramount to this type of implementation. Because that would allow me to say, well, I can go ahead and use some small compute resources, some small virtual warehouses, or maybe an extra small, because this is a relatively tiny workload that I want to execute. I have a small query that I want to run, or maybe I'm putting a whole bunch of analysts, like marketing analysts or financial analysts or whatever, together in their own compute environment to access that same data, and they can use, for example, a small or a medium-sized, or maybe even a large-sized virtual warehouse. So sizing that virtual warehouse, sizing that compute resource is very much dependent on the workload that you have at hand. My favorite example is a company, Deliveroo, in the United Kingdom. They do meal deliveries, as you probably know. Over the weekend, it's seriously busy. So Monday morning, many users come in, many analysts come in and want to know what happened over the weekend. So that would be a peak. At that moment, they would probably be using a large workload, or a large virtual warehouse to support that workload of all those users. You can imagine what happens at 12. Everybody goes to lunch. So then we go back to extra small, or even switch off the entire workload completely. The data will just live there because the data is readily available in that cloud storage. So that's where you have that separation, not only from the compute to the storage, but also the separation of the individual workloads to each other. So the types of workloads that you would implement would of course be all various. That would be loading that data. The speed of slide showing is really going down very much. Is at the end of loading the data. So for example, my favorite data integration tool, like Informatica, like Fivetran, or what have you, are getting data from the legacy systems, from the on-prem systems maybe. It could be data that's already very much well defined, structured data, classically like we see it in classic data warehouses. But it may very well be that this data is coming from external sources. Think the weather, think demographics information, think social media data. That could be what we call semi-structured data. The key to processing that semi-structured data as it's brought into the system, as it's brought into the warehouse, is having the engine, having Snowflake, take a look at the data as it comes in. So the data in itself, as an example, let's use social. Let's use Twitter. The data in itself could be a document, a tweet, but that tweet would consist of many different components, like the Twitter user, the date timestamp, when was the tweet issued, maybe an IP address, maybe a location, these kind of things, and of course the tweet itself and the hashtags inside those tweets. So when data is being accepted, the entire document is ingested into the data lake, but the engine itself understands the data as it comes in, and that alleviates the burden of trying to impose a schema as data comes in, because that schema won't be imposed. It will just what's found, the components of the document will be that are found will be put into the definition of the data automatically by Snowflake. So taking that burden away from the user, not having to build the metadata and the technical descriptions, but just ingesting the data, because that's really the only thing that you would want to do when you start building your data warehouse, when you start building your data lake. You just want to get data in and being able to query it at the very low level. You do not have to worry about all the technical issues that come with getting data into the system, and that's really the key thing. So once that data is into the system, you can go ahead and use your favorite SQL tool to go ahead and query that information. So because the data is in the system, the data is in the data platform, you will be able to query it, and you'll be able, for example, to look for a correlation between, let's say, your point of sale information and what people are saying about you on social media, because it's one platform, it's one data store. The databases next to one another are logical entities, and your favorite front end tool, be it Tableau, be it Power BI, be it Click, be it any of those tools, because they use the standard SQL language, are able to look for that correlation. And the processing power available to you will only be fired up and will only be active when you're actually running your queries. And that's, of course, maybe the most important thing. At the same time, anyone else, like data scientists, for example, who are doing experiments on that very same data, are asking this data, so what can you tell me? What kind of correlations can you give me that I didn't expect? What kind of feature engineering functions can I release on that same data? Because the processing power, the workload, is being kept 100% separate from the workload of those users in the dashboards. So we're separating storage from compute, but we're also separating compute from the other compute resources. And when you don't use it, we just switch it off and it goes away. Excuse me. So like I said, when you need additional power, for example, a data scientist is going to do a big regression analysis. He's going to look for a way to scale up the processing power from a small to an extra large. But at the same time, users of business intelligence applications in their dashboards might be looking to run just many more queries concurrently, so they would scale out. So the system could scale up and scale down for you, but it also could scale horizontally, scale out and scale back in, like in the example of Deliveroo that I was just giving. So having those systems predefined doesn't mean that that the elasticity is gone. This is implemented on an as-needed basis. It's just a flick of the switch and the system scales out. You could even tell the system scale out automatically when there's additional compute resources required. Because that data is readily available in the cloud, because the compute resources to query the data are available on demand, that gives you some interesting possibilities. Like, for example, giving your business partners, your customers maybe, or your suppliers, the capability to have a look at your data, basically exchange data or data sharing functionality to say, well, here's my data, it's in my data warehouse. I'm giving you the access rights to look at your part of that data by using that data sharing functionality. all you would basically need is a URL, a user ID, and a password, and you would get access to your data using your favorite tool, or maybe even integrating that data automatically into your application. That would be that sharing functionality. And of course, the additional functions, as you would expect, because the data is readily available, it can be used in a DevOps, a CI/CD way as well. That data, as it's being stored, like Luca was mentioning, it's being stored immutable in the cloud. So anyone who is doing development, who is building applications next to that live system, would be able to just use clones of that same system. Clone is really a metadata function. So that's something that can easily support experiments of new applications on the data while actually using the entire data set as samples. And the same is true for online backup and these type of functionalities where the data is readily available and slide forward, there we go, where the data is readily available in replication mode. And we have functionalities like time travel. So imagine you are releasing a new version of the application, but you find in acceptance that it's actually abusing the data. You could just use time travel to say, well, let's go back to the status of the data lake as it was before we implemented this mistake. And you don't have to go and get your backup ready and find the backups and restore them and so on and so forth. Like I said, all that work that you would need to do is taken out of your hands by the platform because it's functioning as a service there. So how do we do it? Like I mentioned, we store the data physically in either of the cloud providers of choice. And this is the only, really the only point where you as a user say, okay, I want to have an influence on where my data lives. For example, from a GDPR perspective, you may say, well, I want my data to live in Switzerland or in the Netherlands in Azure, or maybe in Frankfurt on AWS. This is your choice. This is where you put your data to make sure that it doesn't leave the confines of the EU or maybe the confines of your country. From that point on, your data will be stored in that location. It'll be stored in 3 different data centers to make sure that we have disaster recovery implied. And from that point on, you don't have to care about how the data is being stored and how the data is being accessed. Because the only way you would be using the data is by using those compute resources. And hopefully the slide builds up here. You'll be using those compute resources, like I was just mentioning. Let's go back one level. Well, let's leave it at this. So, can I go back one slide, please, Luca? Thank you. So you'd be using those compute resources, which we call multi-cluster compute, which is actually what the user would see when he uses, for example, Power BI to connect to a database. Then a compute resource is opened up for him. He starts doing his work, and after he ends the session, the compute resource is brought down again. How does all those functionality tie together? And that's where Snowflake has built the scale-out services. Scale-out services take care of transactions, for example. Like Luca was mentioning, you would need something like asset-style transactions, making sure that either a transaction completes to the fullest or it's rolled back to the starting point. This is where the management of the whole system happens. This is where the security and the governance of the whole system occurs. Think about not just technical metadata, oh, I see documents, rows and columns, but also I see who has access to that data and how is that access managed. Is he able to update? Can he read? Can he write? And also which parts of the data are available to him. That's where the metadata lives. Of course, the sharing and collaboration that I was mentioning just now. And What you don't see as a user is things like indexing or maintaining the physical data. That's all part of the optimization functionality. So that's the layer that Snowflake brings to the game. So when you use Snowflake for this type of applications, all you do is use compute resources, and those compute resources are then what you actually require to make use of that data. So coming back to that architecture that we were looking at just now, where it's become more of a mesh and less of a mess, so to say. Compute resources are happening dynamically, getting data in, either IoT style data, streaming data, classic ETL processing, classic ELT processing, getting data in for the data warehouse perspective, having compute function when required, as required, is all part of the single platform, which is managed for you, so you don't have to manage it yourself. That's really the high level overview. And if you let me, I can go on for hours about my enthusiasm for the platform, but I'm going to give it back to Luca to extend on the implementations.
Yeah, great, Peter. Thanks. Obviously, we know you could go for hours, but maybe we can ask the question afterwards to the people that were here and see what they're mostly interested in, and then we can tailor next session based on that feedback. That might be an idea, you know, so we can go a bit deeper next time. Obviously, here the goal is to provide an overview of what the capabilities are. So thanks a lot for that. For this view, I really would like to kind of, I retain what I retain mostly is first of all the time travel. It's already, when you say time travel, it's like, what the hell? But then in terms of data, you know, it can be quite convenient. So really going back in history and retrieving some bits of information that maybe you thought were gone. So that was never possible before with the big data platforms, neither with the BI type of systems. So that's quite nice. Then virtual warehouses, I would point that out as well. It's a quite nice feature as well. You could see a scenario where a data science team has their own warehouse, whereas the marketing team has their own. It's kind of like the data marts, I would say, but a bit different, because data marts, you really, it goes to a specific domain, and here it's you can give a whole warehouse, or you select a subset of that warehouse to give to a certain end user. And also cloning and sharing, I think it's also some new features that come in again with this new generation of type of platforms, which are quite important for our users, and we see that our customers are looking for these kinds of capabilities, like sharing to third parties, so really outside of their companies, sharing the data directly from their warehouse, which is obviously today most of the companies do that via some dumps and trying to, you know, or trying to figure out creative ways to penetrate their firewalls to give access to third-party companies, whereas here it's a different approach. And then lastly, like the compute, so what you basically pay per compute, that's also for me a revolution in this domain, because you really pay for per compute, and not really per compute second or something, but not really like paying for resources that are idle. That's quite important. So
yeah, absolutely. And the key thing I would say to do this whole thing is all the functionality that you're mentioning here. All that functionality is working on that single source of the truth. You don't go about copying data all over the place and so on. That data is just that one single storage place where that data lives.
Right. So we have 15 more minutes. So that's more like 10, because we need to give some time for the Q&A and the poll. What I'm going through next is some of the scenarios. So we say cloud data platform or the next generation data platform scenarios, but this is actually what we can observe in the market, what the customers that are interested now in these kinds of platforms what are their traits. So in terms of maturity and number of components, we can classify them in three different types of customers. So those that are looking for new platforms, so probably the ones that have no data platform today, they're using Excel, which is also a data platform, let's say, or they use really old legacy platforms, so legacy BI platforms or just databases to store data. So those are, they have low components, so low number of components that they already have in their data landscape, and we can say they're low maturity. Then the medium ones, so medium maturity, those that want to modernize the existing BI platform, so they have a somewhat modern BI platform, so they want to add a component to treat more information, to have more data, but now probably without going to the data lake or through the data lake phase, you know. So this is the change. We can see some customers today that are on pure BI, but they will not go to Hadoop and then a modern or next gen data platform. They could go to this type of cloud data platform as a next step. So avoiding that complexity with the big data world. And then the last but not the least, so the ones that are most mature, so those that have big data platforms today. So we are talking about how they can evolve the platform with this kind of technology. So in the following couple of slides, I'll just show two examples. So for the two borderline cases. So the use case one for us is a client that needs a new platform. So they have an existing enterprise data warehouse, and we can maybe not even call it an existing enterprise data warehouse. It's a data warehouse used by some departments, and it's quite old, okay, with old technology, not able to scale. And then the client observes limitations, obviously, in it, but their objective is, again, coming back to the beginning, becoming a data-driven company. So using more data, hiring data scientists, and obviously they know they cannot do it with this existing infrastructure. They want to enable advanced analytics, want to do more self-service BI, have scalability, and also at the same time drive the cost. So this is a case where this type of technology, so the new next-gen data platform could be a good fit. Okay. So in the typical, and I'll try to go quick, a typical architecture around that is quite simple. Okay, so we can maybe replicate what we've been doing for years and decades with the data warehouse. We just put this one single data warehouse in the center of the organization, and then we can plug on top of that the reporting, the exposition and exploration type of solutions, and advanced analytics, like Peter explained, and we can do ETLs and ELT, so meaning schema write type of workloads. We can also plug in streams of data, so not talking about batch data anymore. So both streams and batch loading is possible. So we're kind of, it's a very similar type of architecture that we used to have in the BI world, but this central component can take all of the requirements that our customers need in terms of advanced analytics, big data storage, compute scalability, etc., etc. So that's the first case. And then the second case is like I said, the other side of the spectrum, really customers that already have invested in the big data technology, and also maybe have MPP type of data warehouse, really like already scalable data warehouses, but you know, as this typical architecture is too complicated for them to maintain, it becomes too complicated. We see our customers sometimes have teams of 10 or more people just managing the big data stack, because there's so many technologies there. And we see also what customers request from us are type of profiles to help them that know like tens of different, they're experts in tens or more different type of technologies, just to be able to help them, you know, provide reports to the management. And this is really wrong, because they're spending so much resources on implementing some of these data products that they lose focus. Basically, they cannot focus anymore on the business and what the business requires. They slow down the whole business in terms of requirements of data, of what you can get from data. So here the objective is to have a consistent and well integrated data platform, reduce the costs, decommission some legacy components, obviously, and get the data management under control. So we are not here saying in terms of architecture, yeah, replace your storage. We can have the data lake storage, which would be here like a cloud storage, which we say here, which could be an immutable type of storage, but then put Snowflake on top of that, Snowflake type of technology on top of that, so you can get the most out of the data down the path. The loading of the cloud storage in this case should be simple, but then the complexity should be when you start loading the cloud data platform. Okay, so that's how you kind of get rid of the big complexities that you have in between different technologies. Okay. And the rest stay the same. We also can add distributed streaming and operational applications type of workloads in the picture. Okay, this is a typical, let's say, well, it's a simplistic view, but a typical type of components that these very mature companies actually need. So what are the lessons learned in this case? We want to maximize the centralization of data and data services. Okay. Also enable or re-enable self-service, because with the introduction of data lakes and the storage type of a file type of storage, we kind of decrease that self-serviceness for the end users. Okay, and also being able to deliver quick results. Also having embedded data governance and data quality, single source of data, etc., is quite important. Then paying attention to security and existing regulations. Peter talked a bit about it, but we don't have time to get deeper into it. If you're interested in security and regulations, I think Snowflake as technology has a lot to offer there. And also the agility, so not just agile deployment of such platforms, but also how you deploy data pipelines and data products on top of this kind of technologies. So from those lessons learned, we observed that we also as BND, as an integrator, we can really help you and our customers try to advance in that. So we are present in 11 countries. We have a lot of data experts there to help. And we cover a lot of domains like data governance, data road mapping, data labs, and integration type of services that we have and can offer. Okay, so with that, I'll conclude my part, and I'll give the word to Peter to give a few success stories. Peter, you have 2 or 3 minutes to cover those, so good luck with that.
Yeah, thanks very much. 2 or 3 minutes. Oh my goodness. Typically, I need
just keep the most important parts. Huh?
Yeah, absolutely. Well, let's just.
You want me to go back?
I have a couple of use cases here which I would like to describe, and basically really just focus on the highlights from each and every one of them. For me, the highlight in this example is really in the center of the slide under pain points. They had a solution of a data warehouse in the cloud already. They were already implementing or had implemented that, and they were running that, and it was extremely expensive. And why was that? Well, what you see is that the current state of data warehouses in the cloud, from your cloud vendors as well as from third parties, are on-premise systems that are basically just running on a different machine. It just happens to be in the cloud data center. That means that on-premise system runs on a machine in the cloud, and it's 24/7 on. It means it's consuming resources 24/7. It's using the cloud 24/7, and at the end of the month, your invoice will tell you that. This is where Snowflake differs greatly, and this is where Sports Direct had quite some good results. Having those compute resources only switched on, and you would be paying for those compute resources per second only when you're actually querying the system. And when you're not querying it, you know, like I mentioned in Deliveroo, when you go to lunch, the system switches, it suspends itself, and you're not paying anything. So that was quite a point for this specific use case. We can actually go ahead and share these slides with the attendees, and then you can take your time and go through the different slides yourself.
Yeah, sorry, Peter, I clicked on this one, so I don't know if you want to take
that's fine. That's fine. Actually, I was clicking there, but it again took it a little time. This is really the example of basically having an on-premise system, or not an on-premise system, but a multitude of on-premise systems, you know, distributed or across the company, SQL servers, data warehouse appliance. Part was on-premise, some was already uploaded into the cloud. What they now see is that the data from all the different sources is incorporated in one place. The correlation between those different databases has become obvious and easily to analyze. And because that data is already readily available, the performance of getting answers to questions has increased enormously. And sometimes because of that immutable data being cached on the cloud, some queries went down to sub-second response times as well. What did the customer have to do to make that happen? Just load data and start querying it. The system would make sure that it's optimized in such a way. So if you can go forward one.
Yeah, there's the Xerox one, and then I would skip to the last slide, and we'll, like you said, we'll definitely share the slides.
Indeed, this one was an interesting one as well. They had a cloud data warehouse, but like I said, it was an evolution of an on-premise system. So many more users would like to connect to the cloud to get to that database, but because it was an evolution of an on-premise system, it was limited to what the capabilities of that on-premise system. It did not take full elasticity of the cloud into account. So that was a big limitation. Not enough users could make use of the system. And an additional thing they found is that over time Snowflake compresses the data dramatically, and they reduce storage to 20% of the size. So even when storage is cheap, it's always better to have a fifth of the price of cheap, as opposed to many infrastructural costs involved there. So if you move forward, like I said, we can go ahead and distribute these slides to the.
Yeah, so I would maybe stop there because we're running really out of time. I'll put this slide so you can show your logos as well, because I did ours. There are a couple of questions there. So first of all, I'll ask my colleague Bjorn to start the poll. So you can already start the poll, Bjorn. But there's a question that I see from. So you can answer the poll at the same time, but I'll read some of the questions, and those I see there are quite a few questions actually. I didn't notice them, sorry for that, but we'll answer all of them offline as well. A question from Jan Goossens: is this modern data warehouse architecture, are Kimball's conform dimensions and facts still relevant? So it's an interesting point. I would say yes. From my experience, I would say yes. Also, I saw topologies where Snowflake was used to store data in Data Vault as well, then exposed in Data Mart. So I think we can still think about Data Marts, but directly on this type of technology. Okay, that you can then readily consume in your reporting engines. So I'm guessing if you're referring to Kimball and Inman, you are more concerned about, let's say, reporting or managerial reporting than just data pipelines to other third-party players. Okay, so that's one. Then the second one. There's a feedback from Arthur Burkhardt. So Data Lakehouse was branded by Databricks and CDP in the commercial name of the Cloudera data platform. Maybe best to avoid this kind of confusion. I think you're right, yeah, Arthur. We kind of have a notion of the data lake houses. I think some of the experts are talking about this, but here we are more focusing on the let's say cloud data platforms that evolved also beyond just the data lake houses. So they obviously have the some of the features that come from that from the notion of data lake houses, but they also go beyond that. Okay, so but I like your remark. Being that we are a bit out of time now, I don't know if we can submit if the offer was submitted. Björn, can you maybe close? So still collecting the responses. Okay, so I'll just read that question and share with you the results. So what are the main pain points of your analytics platform regarding your current use cases? So first one is lack of functionalities, okay? And then it's followed by not scalable, lack of budget, and the data is not managed properly, so governance in the end. So I think when you when you would say lack of functionalities is about being able to get more data, different kinds of data, and service them to the right audience, which I think is completely correct. If you are in one of those legacy systems. So maybe to wrap up at this stage, I would say we'll follow up with this event by sending you the slides. I'll also try to, together with my colleague Peter, I'll try to reply to all your questions that I see here. I'm so sorry that we didn't have enough time to read through them during the session. But you will receive a written reply by us. And we plan a next event about the next gen data lake on the 18th of June. So you'll get all invited for that, and potentially planning the next ones somewhere in summer. So thanks a lot for your for the feedback and your participation. And I'm looking forward to the next one. Peter, anything else?
No, absolutely. Like yourself, I'm really looking forward to the next one and to work with you on answering the questions.
All right. Thanks, everybody. Have a nice day. Have a nice afternoon.
Thank you.
Bye-bye.